Hello friends, welcome to my YouTube channel. We learn a lot of things during our college days and we are often interested in knowing the applications of the thing that we are learning. Today we are going to see one application of eigenvalues and eigenvectors. Eigenvalues and eigenvector is a part of linear algebra. There are a lot of applications of eigenvalues and eigenvectors, but this video is dedicated to the application which is in Google PageRank. Now look at the following network connections. The numbers denote the websites. That means there are 5 websites and they are labeled as 1, 2, 3, 4, 5. Now you can observe that there is a ray going from 1 to 2. The meaning of this is, in website 1 there is a link which leads to website 2. And there is a ray from 2 to 3. That means there is a link in website number 2 which leads to website number 3. And that is how this structure is defined. Now the most important question is, in this structure, which site will have more traffic? Interesting question, right? This can be answered with the help of eigenvalues and eigenvectors. I am assuming that the audience knows the meaning of eigenvalues and eigenvectors. You must be thinking how eigenvectors play a role here. To talk about eigenvectors, we need a matrix. Here is how we construct a matrix from the given structure. As there are 5 websites, so the size of the corresponding matrix is 5 cross 5. That means there will be 5 rows and 5 columns. We construct the matrix column wise. To construct the first column, we focus at the first website. Now there are 3 outgoing links from the first website to other websites. Now as there is no link from 1 to itself, so the corresponding entry will be 0. And as there is no link to go from 1 to 5, so the corresponding entry will be 0. And rest all entry will be 1 by 3. Because there are 3 links going away from 1. Now to construct the second column, we focus at the second website. We can observe that there are 4 links going out from website number 2. Namely 2 to 1, 2 to 3, 2 to 4 and 2 to 5. So these entries will be 1 by 4 because there are 4 websites going away from 2. And as there is no link to go from 2 to 2, so the corresponding entry will be 0. We can observe that the diagonal entries are going to be 0 because there is no link which leads from a website to itself. Now focus at the third column. We can observe that there is only one link which is going away from 3, and that is website number 3 to 5. So that entry will be non-zero, rest all entry will be 0. And because there is only one, so the corresponding entry will be 1 by 1, which is 1. Similarly for website number 4 and website number 5. Easy to construct, right? We go ahead with this matrix and we compute the eigenvalues and eigenvector of this matrix. So for this I have used an online tool, namely Wolfram Alpha, which helps you to find the eigenvalues and eigenvectors of complicated matrices. So that tool is very useful. The link of the same is given in the description. Now as the sum of each column is 1, so there is a theory which tells you that 1 will always be an eigenvalue of the constructed matrix. We are interested in finding the eigenvector corresponding to eigenvalue 1. So for this matrix, the eigenvector is as follows. This eigenvector contains the ranking of the websites. The largest value present in this eigenvector is 1, which is at the position 5. That means website 5 will be ranked 1. The next largest value is 0.82, which is at the third position. That means website number 3 will be ranked 2nd, and so on. Website number 2 will be ranked 3rd, website number 1 will be ranked 4th, and website number 4 will be ranked 5. Now you can try on your own, create any network connection, find a matrix corresponding to it, use Wolfram Alpha, find eigenvector corresponding to the eigenvalue 1, and decide the ranking of that website. I hope that you have got some idea about the application of eigenvalue and eigenvector. Thanks for watching, and for more such videos, please subscribe to my channel.